So recursion is calling a function f within f. Example, so I have a function named method, and somewhere inside the method I call the same function method again. So what it does is it eliminates the use of a loop. Remember what a loop does? You start from somewhere, you come back to that point again, right? And this loop continues until it reaches a stopping condition. So if you look at recursion, it does the same thing. You start from here, you reach this line where you're calling the method itself. Calling method from this line means you're calling method, so you come from here to here again. So this continues, you execute the lines, and when you reach method again, it works exactly like a loop. Just the difference is I'm not using any loop statement. Instead, I'm calling a function within the same function. To stop a loop, I must have a stopping condition. Similarly, to stop this calling, we also need to have a stopping condition, which is called the base case or base condition or stopping condition, whatever you call it. So this is what a recursion is. Calling a function within the same function. So let us look at a very small example. Before I go to the example, did you understand the or the difference between a void type method and a return type method? In CSE 111, you've solved tracing problems, right? And I believe there were problems where you had to return value and you didn't have to return a value. Where you had to return a value, those were return types. And where you did not have to return a value, those were void types. So let us look at a very small problem or small example where I have to print numbers from 1 to 5. So if you are using a loop, if you were using a loop, this would be your code, right? So you use the for statement or while statement. You have a starting point, you have a condition, and then you increment. So you start from printing 1, and when it reaches 5, it prints, and when it reaches 6, your program stops because 6 would be greater than 5. Now let us write the same problem using recursion. So let's say I have a method name, what should I call it? Let's say met. So I'll have a starting point. I'll have a stopping condition if I is less equal to 5. I print I. and increment I. And if I becomes greater than 5, then the program will automatically stop, right? I missed the main thing, and I call the method again, right? So let us trace what happens. So the value of I is initially 1. So if I is less equal to 5, yes, I is less equal to 5, then I print I, which is 1. I increment I becomes 2, and then I call the same function again, same method again. So from here I go back to the beginning. Well, when I go back to the beginning, my I becomes 1. So according to the method description, I becomes 1. Then the if condition I is less equal to 5, yes, 1 is less than 5. So print I, which is 1. So therefore there's a mistake, right? There's a mistake in this function. What's the mistake? Every time I start, my I becomes 1. So how to solve this problem? There are two solutions. One solution is write I outside the method. If you do this, let's trace. Initially I is 1. You call the function met. You check if I is less equal to 5. Yes, I is less 1 is less equal to 5. Then you print I, which is 1. Increment I by 1. It becomes 2, and then call the same function again. So I start from here. The next line is I less equal to 5? Yes, 2 is less equal to 5. Print I, 2 gets printed, increment I, and then call method again. So is 3 less equal to 5? Yes, 3 is less equal to 5. I print 3, increment I, call met again. Again, I check is 4 less equal to 5? Yes, print 4, increment I, call the met function again. Do the same thing. I print 5 as 5 is lesser as 5 is equal to 5. I increment I and then call the method again. So this time 6 is not lesser equal to 5. Therefore, this condition is this condition did not match. And then I do not go inside the if condition. I reach outside the if condition, which is the end. No more method calls, right? The method call was inside the if condition. As I did not go into the if condition, there is no method call outside, which means my method calling stops. Therefore, my program ends, and my output is exactly what I wanted. Print 1 to 5. You see, these two pieces of code are working in the same way. I mean, giving the same output, or the working procedure is same. Start from a starting point, you have a condition, and then you increment. So for is a loop where automatically circles, and over here there are no loop statements. What I did is call the same method. All right, this is very simple. Questions? Did you understand how recursion works? Yes, no.
Uh, uh, yes, sir. The question I have is about this last method you called. This is a void method, right?
Yeah, this is a void method, right?
So if we replace it with return, it will also work the same way.
I'm sorry.
If we replace it with writing return,
Yes, it's going to work in the same way, right?
okay, sir.
As it's a void method, I am not writing return. But if you add return, it's going to work in the same way. So let me give the underlying picture, what's happening, okay? So as I said in the video, I showed that every method call is saved in the stack. So when I is equal to 1, and when for the first time the method met is called, so you have the if conditions over here. And let's say I have return, I have the word return, for example. So this is the first time I call the method met, and I print 1 incremented I. So over here, I'm calling the function met again. So there is another method call. So each box I'm representing as a stack. Okay, push into the stack. So at first this is pushed into the stack, and then the second method call is pushed into the stack. The third method call is pushed into the stack, and this way up to sixth method call will be pushed into the stack. Okay, because I print up to 5, and then there's a sixth time I call the method met. So this is the sixth time I push the function met, and on the sixth time, my condition is dissatisfied, which means there will be no more method calls. And as will be no more method calls, it will return automatically to the previous step. If you write return or you don't write return, no problem, because it's not carrying any value. It's going to return in the previous step, and then it will it will be returned from this step to the previous step. So every time it's returning to the previous step, this method call is getting popped, 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 and then finally where you're actually calling the method popped. So you understand what's happening. Even if you do not write the word return, it will return to the previous step because I'm not returning any values. Question? I can solve this problem in another way. This is a global variable. So if I tell you that you cannot use any global variable, I can solve this problem using local variables as well. Let me show you that how to do that. So this is your method. I can use an argument inside the function. And when I call the method for the first time, I can, I will send 1 in the argument. And the rest of the statements are same. Except for the fact that when I call met again, I will increment I over here, or I can increment I over here. So this is, I'm solving the same problem using a local variable. Okay, we know that the variables in the argument is local. So if this happens in the stack, I'll have the value saved. Initially, I'll be 1. Over here somewhere, I will be incremented. I plus 1, I will become 2, and then in the method call, in the recursive call, I will send I, which is 2. So this 2 will come over here in the method call. Then met 3, 4, 5, and 6. So in the stack, the local variables, the local values will be saved. The values of the local variables will be saved. Okay. So there are two ways to solve this problem. This is the better approach, using a local variable. We'll solve more examples and things will start to get clear. Okay, let's solve this problem. Print 5. Oh, let's pick a small number. I'll print 3 to 1. I mean the numbers in reverse. So I write the same. So I do this. I have a function, and it takes an argument, and I will be 1 initially. So the user will give me 1 initially, but I have to print the numbers in a reverse way. So look how I do it. So I write it in a different way. If I becomes greater than 3, I just return nothing because it's void. I could have skipped writing this, but I am writing it. Okay. If I hadn't written anything, if I do not write anything over here, no problem. My program will work the same way, but still I'm writing return for you guys to understand. So if I is greater than 3, I return, but I do not do anything because I exceeds my limit. So given else means I is definitely not greater than 3. Remember, the value of I is 1 initially. So if I print I, if I write the statement print I, my program will print the numbers in the correct way, 1, 2, 3. But the question was to print the numbers in a reverse manner. Therefore, I will not use the statement print I right now. What I'm going to do is I'm going to increment I first, call the met function and pass I in the argument, and then I'll do the print. Now let's see what really happens. Okay, let's trace. So this is my first method call where the value of I is 1. and at first I check this if condition is if I is greater than 3. No, I is not greater than 3. So I do not go into this if condition. Rather, instead, I go to the else. Over here, the value of I is incremented by 1. Therefore, I was 1, which becomes 2 now, right? I was initially 1. Now it becomes 2 because I'm adding 1 to it. Then I have these two functions. Wait, let me do this. I will not do this. Okay. I am not incrementing 1. Instead, the value of I remains 1, but I'm sending 1 plus 1, right? I plus 1 while calling the function, and I'll print I over here. So this is my first method call, and I'm saving the statements inside the stack. So before I gets printed, the method is a new method call is invoked. Therefore, this from this line, there's a new method call, but this line is not reached. I could not reach this line print. Before that, a method is called. So therefore, I have to start a new push. This is a push into the stack. So, and in the parameter, I'm sending I plus 1, which is 1 plus 1, 2. So I check again if 2 is greater than 3. No, else. I go to else. The value of I is 2 because I'm not incrementing it over here. What I'm doing is I'm calling the met function again. And I am sending I plus 1 in the parameter, which means 2 plus 1 is 3. So from this line, there will be another method call where I'm sending 3. Is 3 greater than 3? No. I go to else. So the value of I is 3, and I call the make function again, and I send I plus 1, which is 3 plus 1, 4. So met 4. Now look, at this point, when the value of I is 4, is I greater than 3? Yes, 4 is greater than 3. Therefore, I do a return. Return means from this step, I go to this step, and then I see the print statement. When I call the method, it moves to a new box, which moving to a new box means the execution of this line is done. Moving to the new box, and when there's a return statement, I go back to the previous step. Return means go back to the previous step. Which line? At this point. When it comes to this point, it sees the line print I. So right now I'm going to print I, and the value of I is 3. So the first number to be printed is 3. And then as printing is done, there is no return line. No problem. If I write return or I don't write return, does not matter because there are no values. Therefore, it will automatically return from this line to this line, previous step. And then I encounter the print line again, and this time I'm printing 2. After I'm done the print, return to the previous step, print I again, where I is equal to 1, return to the point where I actually call the function. So every time I'm doing a return, these are getting popped out of the stack. All right. So I'm solving this problem in a different way. I could have solved it uh, with the initial value 3 and a decrement. I could have done it that way, but I'm showing it to you this way because of this scenario. Like, what if you encounter a method called before these lines? There are a lot of lines after the method call. What happens when you encounter a method called before other statements? So whenever you encounter a method called before these statements, you complete the method again first. After you're done completing the method, when it's returned, and then you do the rest of the lines. Questions, anyone? Things will look a bit complicated in the beginning, but you need to do a lot of practicing. Okay, as you solve more examples, as you solve more problems, things will get easier for you. And to remember something, when you are solving complex problems using recursion, it's not always possible to trace this way. Okay, this is a very simple problem, very small problem. Therefore, I could trace using boxes. So when you're solving larger problems, it will not be feasible. Sometimes it will not be feasible to draw boxes. Okay, so there's two things that you need to remember, that the two parts of recursion. The first is the recurrence equation. The other is the stopping condition. The stopping condition is basically the condition you put inside the loop to stop. Like, you start from a point, and then definitely you have a condition like this, right? Where you want to stop your program. This is basically the stopping condition of the recursion. So you just write an if condition and put this statement inside the if condition. And recurrence equation is basically what you want to do if you do not reach the base condition. The recurrence equation of this particular problem was print I, or print the number. So I've shown you two examples where both of these examples had no return values. So I'll show you an example where I'll return values. So before that, if you have any questions, please go ask me. At this point, if you slightly understand recursion, slightly, I think that will be enough. As this is the first lecture where I'm explaining recursion, understanding 25% would do the job. But make sure you understand that 25% very well. So do you have any questions? If no questions, I'll show you a new example.
No, sir.
Okay. The next example is factorial. You know what a factorial means, right? In the previous example where I printed 1, 2, 3, or 3 to 1, where I printed the numbers, so this was basically like the building problem I showed in the lecture, where you build one floor and you give the rest of the building to be built by someone else. So exactly what happened in the previous example, you printed one, and then the rest of the numbers were printed by someone else. Then 2 was printed, the rest of them was given to someone else. 3 was printed, and that was the end. Then you returned this step to this one, and finally returned these 2 steps to the previous, where all these were eventually done. Same concept, whether the problem is a return type or not, or a void type. Look at this example. For example, 3 factorial, where 3 multiplied by 2 factorial. 2 factorial means 2 multiplied by 1 factorial. And 1 factorial is the smallest unit, the base case, because 1 factorial is 1. So you see at this step, the mm, so look at this. 3 factorial is waiting for the multiplication between 3 and 2 factorial. So there's a factorial word attached to this portion, but there is no factorial word attached to this. This is a concrete value, 3. But 2 factorial is not a concrete value at this point. So let's pick a bigger example. So let's say 4 factorial. So 4 factorial is 4 multiplied by factorial of 3. So I'm trying to find the answer of the factorial of 4. So factorial of 4 means 4 multiplied by factorial of 3. You see, this is a concrete value, but this is not. There is no value over here right now. The factorial of 4 is waiting for this portion. Whenever there will be a concrete value of this portion, only then I can multiply between this number and this number. But at this point, there is no concrete number. To find a concrete number, I need to find this. Now, to find the value of this, I need to find and as this is the smallest unit, 1, I know that the concrete value of factorial of 1 is 1. This is where I stop doing the factorials. And excuse me. So you understand? Did you understand the scenario? What's happening? So this is a return type. This factorial function should be a return type function because at every step, some portion is waiting for something, waiting for a value from the next step. At this step to be completed, it's waiting for a value from the next step, right? And this step is waiting for a value from the next step. At this step, as this is the smallest unit, factorial of 1, I can easily replace this portion using the value 1. So right now I have two concrete values, 2 and 1. And I do the multiplication and I get the result 2. And this 2 is basically the result of factorial of 2, which was waiting. This 2 will be returned to the previous step. And once returned, this portion can be replaced by the answer 2. And I have two concrete values. I can multiply 3 into 3 multiplied 2 is 6. So 6 will be returned at this step. Finally, I have 6 into 4, which is 24. So this is an example where I'll use a return, well, I'll return a value. So if, let's say this number is n, so this is my base condition. When n is 1, I know the concrete value is 1. Else, what I do is I multiply. Remember, factorial of 4 was basically 4 multiplied by 4 minus 1. Factorial of 4 minus 1. So else, and what I did was, this portion was basically 4 minus 1 is 3. So this is basically 3 into factorial of 2. And the multiplication result of the entire portion was returned. Not just this part. The multiplication of these two numbers, the entire result was returned to the previous step. So else I have to return the multiplication between the concrete portion and the recursive portion. So let's say if it's n. If n is equal to 1, I return 1 simply because factorial of 1 is 1. And if it's not 1, then I return the number multiplied by factorial of the remaining numbers. This is not magic. This is something I saw it from here. I just replaced the numbers using n because the user will, all will, the user won't always give 4, right? So any questions? If there are no questions, then this is the end of today's lecture. What I want to do is go through the box lectures and go through the lecture today. There are a lot of problems, working problems given in box. Try to solve them. Okay, first try to solve them on your own, and if you fail, then you go to the lectures and look at the solutions. All right. The next time we meet, I'll show some more examples, some bigger, larger examples. But I hope I could give you the basic explanation of what a recursion is and how it works.
Yes, sir.
Okay, if there are no questions, then that's it for today.
Okay, sir. Have